All right, now we get to systems of linear inequalities. And that basically just means it's more than one inequality together. We're going to shade for both of these. And when we talk about solutions of these, we're talking about the double shaded area, things that are in the overlapping area between whatever we shaded for the first one and whatever we shaded for the second one. So number one, I'm shading above this solid line. Number two, I'm going to shade below this dotted line. So I just want to graph those and then see where my overlapping green and red area is. So I'm going to just graph the red one first because I already have the red marker in my hand. I have a point of -1, -4. So the point slope form gives it to us as x minus the x value. Like this is x minus the x value. If that's a plus sign, that means it had to be a -1. So that's my point, and my slope is really just given to me, that's 3 there. So I have my point and my slope, now I can graph it. -1, -4, and a slope of 3. So I'm going up 3 over 1, up 3 over 1, up 3 over 1, and this is a dotted line that I'm going to shade below. So I'm going to shade below that line. All right, the green one, that's already in slope-intercept form, so I'm just going to graph that with a y-intercept of -1 and a slope of 2. So from there, from that spot, I'm going to go up 2 and over 1, up 2 and over 1, up 2 and over 1 spot. This one is a solid line. And this one, I'm going to shade above it. So I'm going to shade on top of that line. So it's the areas that are hit by the single area that's hit by the green and red shading. It's where it's getting shaded twice. It's this double shaded area that is right in between these two lines. It's that little sliver in between because it's shaded above this line and below that line. So is 0, 0 a solution? Well, 0, 0 is right there. That looks like that's being shaded by the green one, but not by the red one. It has to be below this red one, which actually, it actually gets farther down into there. It gets down into here. But it doesn't actually get to 0, 0. 0, 0 is not actually shaded by that red. So no, it's a solution for one of the inequalities, but it's not a solution for both. So it's not a solution to the system of inequalities. 2, 4, 2, 4, that is right in the purple area there. So that, yes, that is a solution. So that's system of inequalities. All right, so on number 2, we're going to need to rearrange those inequalities so that we can graph them easily. We're going to change those into slope-intercept form on the first one. All we really need to do is move that 2x over to the other side. So we're going to do minus 2x on both sides. That gives us y is greater than or equal to -2x minus 4. The sign doesn't flip. I didn't multiply or divide by a negative number. So I have my inequality solve for y. This is going to be a solid one because it's greater than or equal to, and since it's greater than, I'm going to shade above that line. The second one I have to do a little bit more. My first step is kind of the same. I'm going to subtract that x over to the other side. That gives me -2y is less than 4 minus x. Actually, I'm going to rearrange that. I'm going to put the negative x in front. Negative x plus 4. And my last step is canceling out that -2 that's being multiplied times the y. Since it's multiplication, I have to divide by that -2. So divided by -2 there, just cancel that out. And I have to divide everything else by -2 also. It gives me that y is now greater than, I divided by a negative, so this sign has to flip, now it's greater than. I'm going to simplify this slope. It's really -1 over -2. I'm going to just change that into a fraction. Really, -1 divided by -2 is the same thing as +1 divided by +2. That's my new slope in front of the x. And the next part I'm just dividing 4 by -2, that's -2. So I have my two inequalities. This one is going to be a dotted line, because it's just less than, it's not less than, sorry, it's just greater than, not greater than or equal to. And I'm going to shade above that one, because again, it's greater than. So I'm going to graph that one first. -2, my y-intercept. My slope is 1/2, so I'm going up 1 and over 2. And that's going to be a dotted line. I got my dotted line, I'm going to shade above that. Now for the blue one, that starts out at -4 and has a slope of -2. I can't really continue going to the right on that. I can't go down 2 and over 1. It doesn't actually go onto the graph. So I'm going to go backwards. I'm going to go back 1 and up 2. Back 1, up 2, back 1, up 2. And that's my inequality. This one's going to be a solid line. And I'm also shading above that. So it's this overlapping area on the top of the graph. When you're doing this on a quiz, make sure you make it really clear where the double shaded area is. If you make it, I mean, this is clear enough, but if you want to, I would even make it clearer than this. And really shade in the double shaded area. Make sure it's really clear where the double shaded area is. Now I just want to decide, are these solutions 0, 0 is in that double shaded area. You can also test these points in the inequalities. You can plug in 0, 0 as the x and the y and see if it actually makes it true. We can see from the graph it will make it true, so yep, that is a solution. 4, 0, that is this point right here. And that might seem like that's definitely a solution because it's on the line, but it's on a dotted line. That is actually not a solution. It is on this dotted line. Anytime we're actually on the dotted line, it's not included in the solutions. That is not a solution. Number 3, we could do something kind of similar. Let's solve for y on both of these. This one, I'm just subtracting that 2x over. So y is greater than -2x plus 2. On the second one, I have to do a couple more steps. I have to subtract the 6x over just like I did with this minus 2x. And I have one more step after that. I get 3y is less than -6x plus 12. And here I'm going to divide by 3 to cancel out this multiplication. So y is less than -2x plus 12. So I'd like two inequalities. Actually, let's go back and just make sure we're clear on this one. This is a dotted line, and we're shading above that. This one is also a dotted line, but we're shading below that because it's saying it's less than. So that is below that. Alright, so we got 4 as our y-intercept, and -2 is our slope. So down 2 over 1, and this one's a dotted line. And I'm going to shade below that. The purple one has a y-intercept of 2 and a slope of -2, down 2 over 1, down 2 over 1, down 2 over 1. And you can see those are kind of running together, and that makes perfect sense because they have the same slope. I kind of missed that one. I'm going to try that again. That's not enough. Still not great, but You get the idea. It's running along those purple points. This one I'm shading above. To me, this is not clear enough where the double shaded area is. It's right in between these two parallel lines. This one is going above the line. The pink one is going below the line. So it's that area directly in between. Now I just have to decide, are these solutions? So 0, 4, that's right in between those two lines. Yep, that is a solution. 1, 1, that also looks like it's good. I can't actually tell though. I want to make sure that, I'm going to actually test that in each of these. So 2 times 1 plus 1 is greater than 2. That's true. 2 plus 1 equals 3, and that's greater than 2. So the first point, or sorry, the first equation, sorry, the first inequality works. When you plug in 1, 1 there, that works. I'm going to plug it into the other one also. 6 times 1 plus 3 times 1. That's 9. That's 6 plus 3. That's 9. And that is less than 12. So actually it works for both of them. Yep, that is a solution also. Right, and we actually just dealt with one of these special cases. These are both parallel lines. Actually, just to save some time, instead of that one, I'm just going to change that to slope-intercept right away. You can tell that both of these are sets of parallel inequalities. And these are kind of the special cases. Really only number 5 is actually the special case. Number 4 is just graphing and shading and finding the double shaded section. So I'm going to do that really quick. I'm going to use green for this one. We have a y-intercept of 1 and a slope of -1/3. And that is a dotted line. And I'm shading below that. It's less than that expression. So I'm shading everything below that line. The next one, I'll keep that in blue. That has a y-intercept of -2 and a slope of -1/3. This is a solid line. It's greater than or equal to. And I'm shading above that one. It's greater than or equal to. So it's this double shaded area directly in between. Those are the solutions to that system. Anything that's in between there is a solution. The second one is similar. I'm going to start out, I'll just keep yellow. -4 is my y-intercept, and 1/2 is my slope. That one's a solid line, and I'm shading below that. It's less than or equal to. That's solid, and I'm shading below that line. The second one, let's go to, that has a y-intercept of 1, and the same slope. Slope of 1/2 is up 1/2. That one's a dotted line, saying y is greater than that expression. So it's a dotted line, and I'm shading above it. It's dotted, and I'm shading above. Alright, this is a special case because these don't have any overlapping area. I'm shading below the yellow line and above the purple line, and they're running together. These are two parallel lines that are never going to intersect, and they never change their slope. So I'm always shading above this one. And I know the yellow one's never going to climb above it. The yellow one, I'm shading everything below there. There's no intersection there. There's no double shaded area. So this one has no solution. It's really the only special case here. There's no overlapping area, so there is no solution for this system of inequalities. Alright, at number 6, I'm going to need to change the first one. Actually, I'm going to need to change both those into slope-intercept form. This will change to y is greater than 1/2 x plus 4. This one is going to change to y is less than, that's going to be just 1/2 x plus 1. Actually, that's going to be a minus 1. Okay, so on this one, I had to flip it around. I flipped this with that. I only flipped that so that the y is on the left side. I didn't flip it because I multiplied or divided by a negative number. Let's just graph the bottom one first. -1 is my y-intercept, and a slope of 1/2. That one is a dotted line, and I'm shading below that. As y is less than that, so it's dotted. And I'm shading below it. It's talking about numbers that are less than that. This one is also dotted. But that one I'm going to shade above, saying y is greater than. So I'm shading above, and it's just greater than, not greater than or equal to. It's dotted line. It starts at 4 and also has a slope of 1/2. This is very similar to the previous problem. Those are also never going to intersect. They're parallel lines, and they're shading opposite directions. I'm shading below this line and above that one. There is no intersection. That is no solution. No solution. There is no intersection between these. All right, here we have another couple special cases just where these aren't exactly in slope-intercept form, and we really can't change the first one in slope-intercept form. I'm just going to imagine this line. X equals -1. X is always -1. That's this spot right here. The entire time, X is -1. That's just a vertical line at -1. This is going to be a solid line. And I'm going to shade to the right of it because it's talking about numbers that are greater than that x value, greater than -1 for an x value. Solid, and I'm shading really to the right on this one. This is the opposite. It's a horizontal line at 3. Y equals 3. Y is always 3. But this one's going to be a dotted line. It's just less than. So that's dotted. And y is less than 3. It's all the y values that are smaller than 3. So 2, 1, 0, everything that's below that dotted purple line. I want to make this a little bit clearer where the double shaded area is. So let's go with green. It is this area that's below the purple line and to the right of the blue line. On number 8, we're going to shade all the points that are solutions to the system of linear inequalities. So there's a couple different ways we could do this. I'm going to plug them in. I'm just going to take all of those points and plug them in and see if they make them true. So let's start with the easy one. That's an x and a y combination of 0, 0. Just plugging in 0, 0 for my x and my y and seeing if it makes it true. I'm going to plug into the top one. Y, or 0, is greater than -7 times 0 minus 16. 0 is greater than, that's just 0, so just greater than -16. Well, that one works. 0 is greater than -16. We still have to test in the bottom one. 5. Let me change color for this. So 0 times 5 minus 0 times 9 is greater than 9. 0 times 5 is just 0. minus another 0 is still just 0. 0 is greater than 9. That is not true, so this is not a solution. I'm going to do the exact same thing for all of these. I'm just going to plug in all of these points. If you wanted to graph these two inequalities and just kind of just look at the graph and see is 2, 3 in the double shaded area, that's fine. You can also do that. Alright, so 3 is my y value, and that's greater than negative 7 times 2 minus 16. 3 is greater than negative 14 minus 16. 3 is greater than negative 30. That is true. 5 times 2, that's my x value, minus 9 times 3, that's the y, is greater than 9. 5 times 2 is 10, minus 27, that's not going to be greater than 9, that's going to be negative 17. That is not greater than 9, so this is not a solution. Alright, plugging in 4 for the x and negative 1 for the y. Negative 1 is greater than negative 7 times 4 minus 16. Negative 7 times 4 is negative 28. Minus 16 is negative 44. So that one's good. Negative 1 is greater than negative 44. Same thing for the next one. 5 times 4 minus 9 times negative 1. That's greater than 9. 5 times 4 is 20. Negative 9 times negative 1 is just 9. That's greater than 9. That's true. 29 is greater than 9. So they both work. That means it's a solution to that system of inequalities. It has to work for both inequalities. I'm going to plug in 0 for x, negative 2 for y. That's going to give me negative 2 is greater than, that's still just 0, negative 16, that works. Negative 2 is bigger than negative 16. And I'm going to plug it into the bottom one also. 5 times 0 minus 9 times negative 2 is greater than 9. 5 times 0 is just 0. Negative 9 times negative 2 is positive 18. That's a plus 18. That's true. 18 is greater than 9. It worked for both of them. Right, last one. Plugging in negative 5 for both of them. Negative 5 is greater than negative 7 times negative 5 minus 16. Negative 5 is greater than, that's going to be 35 minus 16. Actually, we don't even need to test the second one, because this is not true. Negative 5 is not greater than, that's 19. Negative 5 is not greater than a positive 19. So it'll only work for those two. Okay, I was gone for a minute.